Hey guys, welcome back again to the NLP second day lecture. Apologies that it was 3 minutes late from my side, so apologies for that. So today we are going to be working on some of the great projects, very beginner friendly, and we are trying to understand that how we can go with the NLTK. So if you remember about the yesterday, we were having a great discussion about the NLTK and so many different libraries. We were having LNLTK and we were having that Stanford NLP. So we were having so many different libraries which we discussed yesterday. But today we are going to be working on something different, trying to understand that how the NLP programs can actually work, right? So that is something which we are going to work today. We are going to be focusing on the computational neural networks. We are going to make a project on that, a very easy project. It's not going to be very hard to understand, but still it's going to take some time, right? uh, so today we are going to be working on two projects overall. The first project is going to be based on the sentiment analysis, based on the text. If you came yesterday to the live, or if you have watched the video of the yesterday, it was quite easy. So we were having some words. Based on those words, we were having the positive review or the negative review. So giving and making it more complex and more a little advanced, today we are going to be working on that. Apart from that, our second project of today is going to be sentiment analysis of the human faces, detecting if a person is happy, sad, angry, or whatever. So we are going to be train the model, we are going to test the model, and how it basically works. So we are going to understand that process as well, because many students have a problem in understanding about training the data and testing the data, and ultimately how we can do all these two things, which is training and testing. And at the very last, we are going to be having a program which is going to be taking the model which we are going to develop today. All right, so let's begin from today. It's going to be very awesome lecture if I'm not wrong. So let's go on that as well. All right, so first of all, we are having our PyCharm here. I already introduced you for the PyCharm yesterday, that what is a PyCharm, how we can use PyCharm for Python programming, and how the Python programming can be used in the natural language processing. So as usual, our first project is going to be what? It's going to be the project 1. So we are going to be taking the project 1 as going to be sentiment analysis based on what? It's going to be based on the sentences or the text. So let's take the text. That means on social website, if you are going to be having a conversation, or if you're posting, and in the caption, if you're writing a positive word, then of course ultimately the post is going to be having a positive review. But if you're saying something negative or bad, so of course it's going to be having a negative review, which is going to be a part of sentiment analysis. And of course, if your post goes against the Instagram policies or Facebook policies or YouTube policies, so your post is going to be removed. So that all those things basically comes under the sentiment analysis, which is a part of textual things. Now of course we are going to be having the photological things. That means based on photos, the algorithm can work, or the program can work, right? So right now in this project, we are not going to be developing any kind of CNN, but after this project, the project 2, which we are going to do today, is going to be having the CNN. So it's going to be really awesome, really fun. We are going to be having a lot of errors. So we are trying to fix that as well. But hopefully if you are not having the errors, it's fine. If you are having errors, so we have to resolve those as well. So all right, let's start today for the project 1. So we are going to be importing the NLTK. So if you remember, we were having the NLTK yesterday, which was natural language toolkit, right? So we were having NLTK. Now what we are going to do is that from NLTK, now, as I told you yesterday, that there are so many different, we can say, functions inside a module that we can use. So there is a tokenized model we are going to use under the NLTK. Now from NLTK, we are tokenized, we are going to use import. What we are going to import? We are going to import the word tokenize, because we are going to focus on the word of a sentence, if it is having a positive review or a negative review, or if the word is having a good polarity or a bad polarity. If you remember about the yesterday session, we were having about the discussion based on the polarity. If it is more than 0, it is a positive polarity. If it is less than 0, it is a negative. It is exactly zero, it's a neutral polarity, right? After that, I'm going to be taking a second item, which is going to be sent the tokenize. So it's really important. Now here, as you can see that we are having three important terms, which is going to be getting the word tokenize and sending the tokenize, and of course using the tokenize. So we are having three important items. So that is something which you have to follow. If you are going to write the program with me, so it's awesome, because if somehow I make a mistake, so you can just let me know that I had a mistake in the comment section, right? So I'm also trying to note down if I'm going to be having some mistakes in my program, but still if you are yourself writing, so it's going to be really awesome. All right, after that we are going to be taking from NLTK. I'm going to be taking another function, which is going to be corpus. So corpus is something which basically gives us an advantage of making the polarity more and more stable, right? So corpus is kind of like a module or a function under the NLTK, which gives us authority to have our polarity more and more fixed, or having more and more better, or having more and more, we can say, better values for sure. I'm going to be using import stop words. All right, so I'm going to be importing the stop words from the NLTK.corpus. It's going to import the stop words. Now we are going to be understanding all these things later on if you're new to Python, but if you already know Python, it's really good. Now again, we are going to be taking some statement from NLTK.sentiment. Of course, we are going to be working on sentiment. We are going to be importing what? Sentiment intensity analyzer. So it's really important. So we are going to take sentiment. So here you are having already two options, sentiment analyzer or sentiment intensity analyzer. So today we are going to be taking intensity analyzer, right? So it's really important that you are going to be taking this particular function. All right, after that we are going to be downloading some NLTK resources. Already we discussed yesterday. So again, I'm going to tell you that we have to download some resources, right? So let's download those. So the very first download I'm going to be taking is Punkite. If you remember, so we were having Punkite yesterday, or Punkite, so it depends how you pronounce it. So I'm going to be taking the NLTK.download. So I'm going to be taking a download function. Inside this, I'm going to be writing Punkti or Punkati, depends on how you pronunciate. So this is going to be the first module I'm going to be downloading. After that, I'm going to taking NLTK.download another module, which is going to be having the name stop words. Right? So we are going to be taking the stop words as a second module. And after that, we are going to be downloading one more module, which is going to be Vader lexicon. So it's important you guys remember. So Vader, and I think so it's lexicon. Lexicon. Hopefully, if we are going to be getting some errors, so we will be checking, we will be trying to check if we are having some errors later on, but fortunately it should work. Right, so Vada lexicon is something which is going to be telling the sentence if it is having any type of grammar mistakes. So if a sentence is fine, it's fine. But if a sentence is having some grammar errors, so the Vada lexicon module or the function is going to be checking if the sentence is having a grammar error. So it's going to be giving us error into a form of output. All right, so this is something which we are going to be understanding. And after that, we are going to be, trying to write some sample text. By the way, you can read here if you want to go. You will be having some information about what we are doing right now. Now, after this thing, I'm going to be using some sample text. It can be anything, whatever I want to write. So I'm going to be taking a variable with the name sample text. And inside that, I'm going to be taking any kind of thing. You are good. So let me just write this sentence. You are good, right? Is this enough? For we can change the sentence if we want later on. So that's it. This is a sample text variable which we have declared, and the sentence is you are good. You can take anything. We will change for sure, and we will see what is the result we are getting. Now another variable which I'm going to take is sentences. So we are going to be declare the sentence with the tokenize whatever we have tokenized. So send.tokenize is going to be sample text which we have declared above. And after that, we should take something another variable for the intensity analyzer, because here if you see we have taken the sentiment intensity analyzer, so we have to declare this also somewhere. So let's take another variable. It can be anything. Let's take sia or hi. So let's take sia, right, because it's a short form of sentiment intensity analyzer, so you can just take short form if you want. So I'm going to announce this as this one. And I think so there is nothing to declare inside this particular function. So after that, we are going to be using for sentences in sentence. You can just take vice versa if you want, for sentence in sentences. So now, of course, we are having one simple sentence above "you are good." Now that is being declared into the tokenized manner into the sentences. So overall, it's similar. So words, I'm going to declare words as a word tokenizer. So I'm going to be taking word tokenize here. Sorry. So it's going to be word tokenize, and inside this I'm going to write another sentence. All right, it's not going to be sentences here for sure because you have already used sentences above. After that, what we can do is we can just try and go with some stop words. We are also using stop words, so we have to use the stop words also in this program. What we can do is we are going to be using words, and we have to remove the stop words. So it should be maybe it should be word lower or word upper. All right, so what it's going to be, so we tokenize the sentences. We are going to be having the word dot lower function. Let's take lower function here. So word dot lower. So we are going to be having for so where the words are going to be lower. Suppose for in words, so if word, so let's take isilnum. If the word is not a number, right? So if a word is not a number, so here there is error. So for word in words, I think so now this will resolve. Yeah, for word in words, if word or isilnum. So isilnum is something which gives us the numerical value of the word. So if there is a number inside a sentence, so it's not going to be taking that into consideration. So this is something is isilnum. And after that, I'm going to be taking another property, which is going to be and word if word dot lower itself. What we can do is, so we can check for the sentiment intensity analyzer, right? So what we can do is not in stop words, right? So it's not inside the stop words dot words. Inside this, it should be English because we are using the English language. So it's going to be using only English, right? So yep, that's fine. Let's go ahead. And after that, we are going to be having some sentiment score. Like yesterday, we were having some sentiment score. If it is more than 0, so it's positive. It's less than 0, so it's going to be negative. So what I'm going to do is let's try to add a sentiment score here. So sentiment, we can take score. So we are going to declare a variable here, sentiment score, equal to cia dot we can take polarity scores, and in polarity scores function we are going to be declaring this, or you can just take single, it doesn't really matter. After that, we are going to be having the function dot join, and inside that we are going to be taking the function words. Hope so till here everything is fine. Still, like if we are going to be getting some error, so we can resolve that later on, but fortunately I think so there is no error. So now we are going to be setting the score. So if sentiment score, if sentiment score, let's take is compound or what we want. If the sentiment score is compound, so we are going to be taking compound, and if this score is more greater than or equal to 0.05. Now this is something which is really important. Yesterday we were not having any kind of decimal values, but today we are taking, because we are using intensity manner. So if you are using the normal sentiment analyzers, it's fine. But today we are using the intensity, which is kind of like a more complex manner to understand about all these things. So once we are gone with this, so we are going to be label. So we are going to do a label, right? So sentiment label. So it's going to be positive because it is more than 0.05. So we can take that into positive, right? I think so it's fine till here. After that, as I told you that if we are using if, so we are going to use elif. So if sentiment score, again we are going to use a compound. So compound. Now we are going to be taking the value less than or equal to 0.05, 0.05. So we are going to be giving it a label, sentiment label. So we should be getting the negative, right? So we can give the value as negative. And of course, at the last, we are going to be having neutral, which is going to be else. It's going to be neutral. So sentiment score or sentiment label is going to be neutral. I think so that's fine. Yeah, that's fine till here. Now at the last, we are going to be taking some print statements. So what we are going to print? So we are going to be taking function inside this, which is going to be f, and after that, what we want. So sentiment, after that, the sentence which we are already having above. So sentence dot strip, because we are taking the strip values here. So it's going to be strip values. I think so that's fine. So after that, we are going to be having print if sentiment again. Now this time we are having the label. So we are going to take sentiment dash label. So yep, we are having this. And that's it. I think so we can just go with the print. And this should give us ultimately the positive review of the sentence, you are good. So we can change the sentence here. And once we change the sentence, we are going to be having a different kind of, we can say, output. So we are going to change the sentence as well. So let's run the program. And so yep, here you can see, if you are unable to see, but still I will try to show you that what is something which we are getting as a result. So here, if you can see, we are having you are good as a sentiment and the label is positive, right? So what I can do is I can just try to change a sentence and see if it is giving us any negative or any kind of thing. So if I'm just going to say, instead of good, you are bad. So if I'm going to say you are bad, now if I'm going to run a program, so now you can see that instead of giving positive, it is giving us negative. So because you were using you are good, you were having positive, but right now you're using the bad word, it is giving the negative values, which is kind of like telling us that yes, the program is working really fine. So of course we were using NLTK by default, that is already having the index values of all the words which we are using. But still you get an idea by like how NLP actually works based on the text recognitions, how the program actually we can develop. Now this was kind of like an intermediate advanced level program. It was not total beginner friendly, but still it's a good start, right? It's really a good start that you are trying to make your own NLP programs. By the way, whatever we are learning, we are trying to go with the capstone project, because it's really important to have some capstone materials so that you can develop, you can try based on the industrial based, we can say, the projects. All right, so it's really important. Right now we are having the sentences. Now if I want, I can just change like any sentence I can just write here. So it is going to give us the sentiment label. The day is good or the movie is good. So what I can do is I can run here, and again you can see it's positive. And if I'm going to write the day is bad, so again based on the bad word, it is going to be giving us the negative. Let's try with some more people or having some persons. My friend uh, is really good, but he is not so, we can say, sincere. So now here I'm having a neutral, but still depends on the program. The machine is unable to understand the words or the sentiment actually behind the scenes, which the machine is not having the consciousness, of course. But based on my sentences, based on the words which I'm taking the good, uh, of course in the second one it's good, right? So my friend is really good. So based on all these words, sentiment, what I'm getting is the positive one. So this is actually very, very important to understand that how actually the NLP works, right? I think so you guys really enjoyed for the project one, which we have done right now. Right now, we are going to be taking the project two, which is going to be working on the computational neural networks, convolutional neural network CNN, and we are going to develop a CNN model. And based on that model, we are going to be checking out the emotions of a person from the image. So if you want, you can upload any required to be having these things, right? So I think so it's working. Yeah, it's working fine. Let's cross this notification. So yeah, that's really important. By the way, you are going to be needing some of the pre-default files, which is going to be the happiest.xml file, which is we can say uh, the latitudes or the longitudes of the face, right? Not latitudes, longitudes, but kind of like telling you the coordinates of the face, right? So this file is really, really important to have if you want to be making up the program. Apart from that, we are going to be needing this particular file, which is going to be fair2013.csv. So this is something which you have to just search, which is going to be FER 2013. Once you actually go onto this website, which is the Kaggle. So here you are having the emotions data set. As I told you that it's really important to have a data set, right? Because we are going to train the model, we are going to tell the model that this is something which you have to understand. And like there are thousands of images in this particular data set, thousands of images which are based on happiness, thousands of images based on angry, and so on. So we are going to train, we are going to develop a model, we are going to tell the model that this is something you have to take, and based on that, the model is going to be developed. We are going to use that model in our program, and ultimately we can understand that how basically all these things work. Awesome. So first of all, you have to download this particular data set. Now I'm already having downloaded. So you just need to search FER 2013. Now this is a very good data set, right? Once you actually search this, it's going to be around 63 MB. It's not very huge size. After that, you have to just search for .csv, right? So you have to search for .csv because by default in the previous one, it was not available. So once you search for the CSV, it is going to be 101 MB, right? So you have to download this CSV file and the data set, and all these things should be inside your folder. Now here, if you see, I'm already having FER 2013.csv. I'm having Harrisgate front face default.xml, two files I'm already having, right? Apart from that, I'm also having the testing and the training data set from that only, from the previous one. So I didn't make any new program right now. So all these things are available inside the things which I told you. The two things you have to download, one is FER 2013 dataset, one you have to download FER 2013.csv. The third one is going to be Harrisgate, the front face default.xml. So these three things you just Google on, you can download from the first link, not very difficult, easy to understand. So once you have these three things, make sure to have your images which you want to test into the same directory. So right now I'm having the image here into the same directory in which I'm having up my CSV file and the front face default XML file, and of course the training and the testing data. So you should be having the testing images on which you want to implement into the same folder. And the files which I told you are really, really important, especially the .csv file is really important because it is having the coordinates once a person is happy. So the lips are having, that movement, what is the movement, what is the coordinate of that point. So this CSV file is having a lot of data points. All right, so the CSV file is really important in order to develop your own model. So we are going to be developing our own model. It will take some time, but fortunately, hopefully we are going to develop that for sure. So if you are not having any problem, that's totally fine. But if somehow you are having any problem, you can just comment down. We are going to be working on more and more, we can say, um, projects in the coming time, not only on NLP but on the machine learning. And absolutely we are going to be having more and more awesome stuffs, we can say, coming on. All right, so hope so this is going to be something which, once you do, is going to be making you at least a good beginner friendly person, to understand how all these things work. All right, so it's going to be really awesome. So right now let's go for the project 2, which is going to be easy to understand. So let's delete this one. All right, so now we are going to be working on the project 2, which is going to be sentiment analysis, or the emotion, we can say, detection. So emotion detection using sentiments. All right, using sentiments. Now this one is coming from the images. We are going to develop a convolutional neural network, and based on CNN we are going to develop a program, and it is ultimately going to detect if a person is happy or sad based on that particular image, and of course the face. It's going to be really important. All right, so for this we are going to be require the NumPy. So we are going to be having NumPy. So if you don't know about NumPy, so it's a quite popular library in Python. Import NumPy as NP. By the way, I told you how can you download. Go to the PyCharm, go to the settings, and on interpreter you are having these particular things. You can just search here for NumPy or any library which you want to install, right? So I'm already having installed, but sorry, you can just try and go and search here. So you can see that I'm having NumPy. You can, by the way, you also have to install the TensorFlow and the Pandas for this particular project. So you can just search for Pandas, and once you have your Pandas, you can search for that. Apart from that, you also have to go for TensorFlow. So TensorFlow, you just need to click on install package. Once it's completed, it's fine. I already have installed, so I'm not going to install again. But you just need to have TensorFlow, Pandas, and NumPy in order to make this project, and the files which I told you. So right now, whatever the program I'm writing is going to develop the model, right? So we are going to develop a model by using the CNN. So how the CNN program actually looks like, how we can develop the model, we are going to be watching that right now. All right, so import NumPy as NP. After that, I'm going to be taking import Pandas. So it's going to be Pandas as PD. That is something which is universal. Now I'm going to be taking import TensorFlow as TF. So this is something which we take when we import TensorFlow, and we are using TensorFlow from TensorFlow.keras, because that is something I told you yesterday also, TensorFlow and Keras. I'm going to be importing some important modules like layers and models. So because we are developing a model, we have to add some layers, we have to add some coordinates, and we are going to develop a model. All right, so it's going to be the very basic and the very starting step for creating a model in the TensorFlow. Now what I'm going to use is that I'm going to use FER2013.csv, which is the default data points of the face structure, and based on that CSV file we are going to develop, or we can say export, a model. We will use that model in the program. All right, so it's quite easy, not very difficult. So we are going to be taking now define load. We are going to be loading FER2013.csv, right? So it's going to be like this, but not here. I'm not going to mention here. So once I have this, I'm going to be making a variable that is data.pd, which is going to be reads or read.csv. I think so, yeah, here is an option. And in CSV, I'm going to be giving up the CSV file, right? So let me just copy up the path from here. So once you select this, go to the copy path reference, click on absolute path and paste it here. So this is actually the absolute path of my CSV file, right? So now I can go in pixels. I'm going to give another variable, which is going to be data. and in data I'm going to be having pixels to list, right? So it's going to be giving the to list. That's it, right? So right now we are developing a model, we are developing a CNN program right now. So please pay attention if you don't know how to make a program under a CNN. So width and height we want to give to the face is going to be based on 48, 48. Let's take that coordinates 48, 48, right? So we have taken two variables and given the we can say values, float values. After that we are going to be having a variable faces. That's it. It's going to be empty. Not very difficult to understand, easy. Have I made any error or no? Till here I think so everything is fine, right? So even though if we are going to be having some error, we can check that later on. Now after that I'm going to be taking for pixels or pixel sequence. For pixel sequence, now this is something I'm that declaring for pixel sequence in pixels. And here we are going to be adding some face values. So the pixel are always in the numerical value, so we are going to be taking int. So pixel should be pixel. Now again for pixel in pixel sequence dot split, we are going to be splitting the face into two so that it can understand more properly. And after that I think so that's fine. Yeah, that's okay. Again we are going to be giving face and we are going to use np library, which is numpy. We are going to be using as array. We are going to be using face. We have to check for the reshape value if there is a reshape. Yeah, there is a reshape function, so we can use reshape, width and height. All right, so I think so that's it. And after that if I want to check for any other faces, so I'm going to take faces dot append, and inside that, by the way, let me just check if we are having any problem or errors. I think so till here everything is fine. Faces, pixel sequence, reshape, faces dot append. In append we should be writing face dot as type. So if I'm not wrong, yeah, there is a function as type, and it should be float into the numerical values because we are taking CSV. So we are going to be taking this particular thing. All right, it's going to be float 32. Right, so I think so it's fine. Still let me just check out. Right, got it, it's fine. So I think so everything is fine here. All right, let's move forward. Now I'm going to be taking faces. It's going to be np.array again, np.array, and it's inside that it's going to be faces again. All right, so after that we are going to be taking again faces. Now we are using expanding because we have to understand the face structure. So the face structure can be long, the height can be long, it can be short, the data points can expand. So based on all those parameters we are going to be taking here. So np.expand. So we are having expand dims. Yeah, so expand dims, we are going to be taking faces. It can be -1. So let's take this parameter right now. By the way, you can take 1 also or 0, but don't try to take more than 0, otherwise it's going to be a lot. So this particular line actually tells that what can be the maximum stretchability of a face scan, how a face can be stretched. So -1 is something which is, I think so, is fine, but +1 +2 is something which the face cannot exist, right? After that, what we can take is we can take emotions as a variable, because we are using PD for emotions. PD dot we can say get dummies. Yep, get dummies is a good one. So data emotions, emotion, right? So emotion dot to numpy. So no parameters here is fine. After that, we are going to return the faces or emotions because we have taken two variables of faces and emotions. So let us just check if everything is fine. Okay, everything is fine till here. We have used a CSV. After that, we are having the data pixels to list width and height of the face is fixed. 48 by 48 faces is going to be empty parameter. Pixels is going to be into the digital values. It is going to be int. Pixel sequence is split, width and height are declared. Faces nps reface. Reshape is fine. Append is fine. Is float 32 and faces -1. Emotions. All right. I think so. It's fine till here, but let's try to run the program, and then only we will be able to understand it's fine or no. After that, what we can do is we can go for another developing the CNN model from here. Now from this line, please pay attention because we are going to develop the model, how actually it looks like, right? So it's really important to understand how basically it looks like, and it's overall the important part. All right, so pay attention here. So we are going to be building the model. So we are having build model. Sorry. So we are having build model, and inside this build model, we are going to be declaring input shape. Input shape, right? So now from here, we are going to be using model command. So once you are using this particular thing, so it's going to be, of course, the model, we can say declaration. So we are making a model right now. So it's going to be sequential model. So sequential, I think so it should show, but unfortunately it's not showing. It's showing an error, but hope so it's going to be working later on. Model, or it should be models. Okay, it should be models. After that, we are going to be having model dot add. So we are going to be adding the layers. So layers is going to be based on the what was the convex mirror or the concave mirror. So we are going to be using con 2D for this particular thing. So we are going to be taking layers conv 2D, if I'm not wrong, conv 2D, and the values for the parameters for this is going to be 32. And after that, we are going to be taking 3,3, right? So the activation value is going to be, the activation is going to be based on ReLU. By the way, you have to read the documentation for the model making. It's not very hard, but you should know ReLU and PPEIR or something like EPR. So there is something which is known as blue. So all these are different kind of data points which actually tells, like animals. In animals, when you are doing, so it's a PPR, right? When you're doing on buildings, it's a kind of blue. So on the humans faces, it's ReLU. So you have to read all these things, especially the documentation file. If you don't read the documentation, it's kind of like hard for you to understand. And once we are having this, now I can go for the input shape, which we already have declared. So we are going to be taking input shape is going to be equal to input shape. All right. So I think so everything is fine here. So that is something which we have done. After that, we are going to be adding some more values here. So, all right. Now what we can do is, let's copy this one because we are going to use this every time. So now we are going to add the layers again, and we are going to be using max pooling TD. So max pooling 2D. So all these are important parameters. We are going to be using 2,2. Awesome. After that, again we are going to be adding a model. So in this we are going to be using again layers Now we are using different layers. We are adding the layers inside the model. So layers.conf2d again. Now in this, I'm going to be taking parameter 64 or any kind of parameter 65, 70, the human face structure or the length and the height again. So 64, 3, 3 is fine, I think so. Now after this, again, we are going to be taking the activation of ReLU. Activation equal to ReLU. I think so, yeah, that's fine. All right, now again we are going to be taking model add. From here I'm going to be taking again the max pooling 2D, because previously we gave for the conf 2D for the different values. Now previously we were having 32 conf 2D, now we are having 64, and after that we are going to take 128 and so on. So it depends. The more model you are, the more layers you are going to add, the better your model is going to be. So we are going to be limiting till 128 is fine. So for 64 I'm going to be taking 2 that's fine. So I'm going to be copying up this thing and pasting it here. So I think it's fine. All right, sorry. So now we are going to be taking conf 2D again, this particular line again, pasting. Now we are going to take 128 here, and in this I'm going to be giving the value 333, and ReLU is of course going to be there. And after this, let's go here. So input source, by the way, it's not required, right? Because we already gave input source. So this particular thing is not required. So what we can do is we can delete this input shape, because ReLU is fine for us. All right, now we are going to be giving the max pooling 2D for 128. All right, so we are having, we didn't took, so all right. Oh, sorry. So we are going to be taking all right, max pooling 2D is going to be again 2.2. So that's it. After that, at the very last, we are going to be adding another layer, which is going to be the last layer, model dot add. So it's going to be layers dot flatten. So it's hard, right? Developing a model is really hard under the CNN. It's really hard. So after that, it's going to be flatten, and we are going to be adding another layer, model dot add layers. So it's going to be dense value. So we are going to take dense. For the dense, we are going to take the values and parameters 128. Activation is again going to be ReLU, right? So activation is again going to be ReLU. All right, after that, any other if we can add. So let's take another dense value so that there is no problem in the model. So model dot add layers dot dense. Now inside that dense, I'm going to take another parameter, which is going to be 7, and inside 7 I'm going to be taking activation, and for the activation I'm going to be taking softmax this time, not ReLU. Softmax. All right, this basically 7 recognizes, or 7 basically tells here about the emotion numbers. That means I'm angry, happy, sad, excited. So this 7 number actually tells how many emotions we want to develop in a model, right? So this 7 is actually like that. All right, so after that we are going to be taking for return model. So once I have here, So what we can do is we can go here and return the model. So it's going to be return model, right? Anything else if we want to add is going to be the data points of the face. So we are going to be taking two items, faces, comma, emotions. It's going to be, we are going to be loading for 2013, and we are going to be taking faces less than or equal to 255, which was the float 32.0. So this is going to normalize the pixel values. That means it's going to be telling us to have the normalization in the pixel values. All right, so once we have this, we are going to be getting the split use here. So we are going to be using split variable int 0.8 times, we are going to be taking length. We are going to be taking length of faces. Now we are going to train the model, which is going to be xtrain. So we are going to taking xtrain and ytrain. So let's reduce the size. Xtrain, ytrain. So we are going to be taking faces. We are having split. So we are using the split. Right after that, emotions is split. Right, so we are having X training model for the faces and Y training model for the emotions on those faces. Now for the testing also, we should have the same parameters. So X test, Y test. So it's going to be faces. Again, for this, we are going to use a split because it is a finalized version. So we are going to be having split here, and emotions again split, and that's it. Now we are going to be at the last building and completing the model. Previously we have built, but right now we are just going to complete up the model. So what the model should be having is, it should be having the input shape. So let's take this one, input shape equal to x train, because we are taking the train data first of all. So x train, inside this we are going to be having 0 because the model hadn't been trained yet. So x train dot shape. So we are going to be model build model, which is going to be input shape. Right, after that we are going to be compiling the model at the very last. Model dot compile is going to be something. We have to optimize the model, so we are going to apply the parameter optimizer. All right, optimizer, the value should be Adam. So as I told you that you should be know about the human model, it should be Relu, and if you are using optimizing values for the humans, it's going to be Adam, right? So you should know all these things, it's important. So Adam, and I'm going to be using the loss. If there is any loss, there is not accuracy, so it's going to be categorical cross entropy. So maybe yesterday we used this as well, cross entropy, right? After that, another parameter, which is going to be the last one. So what we can do is metrics. So metrics is left on right. So metrics is going to be having the accuracy. Right. So it's fine till here, and let's close this. So I think so everything is fine till here. All right, let's see if it works or no. After that, we are going to be fitting the model dot fit. So we are having x train y train. So we are going to be having validation data equal to x testing and y testing. X test and y test. Alright, after that it should be epochs value should be 10 around or around 0. It doesn't really mean, right? So you can take 0 as well if you want. And how many model sizes we want? We want the batch size of around 32, right? Alright, so I think so that's it for the model generation. And at the very last we can use the function model.save, and it is generally going to save the model. So model.save parameter with the name. If I want to have a model parameter name, so I'm going to save the model name with the emotion model. So emotion model, and remember that whenever you are using the CNN and you are going to export or save an emotion model or any kind of model, it is always having the extension of h5, right? So this is something which is really important. Whenever you are saving or you're creating a model or whenever you're downloading a model, it should be having an extension of .h5. So this will take some time, if I'm not wrong, if it runs properly. I think so this should run. There is an invalid syntax which is return model. All right, so there is syntax error, line 34. All right, so return model is having a problem here. But it looks fine. So let's try to have checking the error. Right, so it's fine, it's fine. So it's invalid syntax. So it should be running. Oh. All right. Let's check. All right, so it's fine. It's fine. Everything is fine. 52 accuracy. So if we go above TensorFlow, right. So it should work. So it's working, right? Right. So sometimes the program doesn't work, so you can just try from your side. It's working, right? So let's wait for some time because this is going to take a lot of time to develop the model. Right now you can see it is going to be taking 10 we can say sets. So out of 10 different set, it is going to be telling us it is going to make a model out of those 10 sets. All right, so let's wait for some time, at least for 5 minutes. It's going to be making up the model from that. By the way, if you're having any questions, you can just let me know. I know it's really hard, but still. So by the way, this is the way through which you generate a model, right? It's kind of like curiositical, fascinating, but still it's hard. So in the previous semester of my study, we developed a model. So it's easy for me to remember all these things. because I learned all these things. I remember how to develop a model. So it was kind of like easy for me because I already worked on this particular 40 or 45 lines of code in the last semester. So it was quite easy for me. So if you also want to go into the model, or you have to develop a model, make sure if you're not good at Python or any programming language, you should at least learn or remember the syntaxes and the commands, or we can say the lines. That's not really difficult. NumPy, pandas, we already know how to import those things. We just need to learn or remember these particular things, right? So it's not very difficult or very hard to understand or very hard to develop. All right, let's wait for some time. Now it has reached for the epoch of 5. All right, let's wait for some time. Now once it is going to be completed, you will be able to see here the name of the file, which is going to be emotionmodel.h5. So you will be able to see that a file is going to be generated here. So let's wait for that. By the way, if you're having any questions or doubts, you can just ask in the comment section, right? We would try to give you the answer. So 7 of the epochs have been done. 7 set has been done or completed by our model. So 3 more sets are going to be made and the model is going to be completed. So it's going to be easy to make a program, use this model and check out our image. So that is going to be it. It's not going to be very hard. So it's almost done. All right, so it's done. Now you can see that we are having our model, emotion model.h5 here, right? It's written here. If you see, then this is the model which we have generated. Now we are going to use this model inside a program to check out the emotions. All right, so it's going to be easy. Let's have our last program of today to use this model and check out the emotions of the image, right? So we are going to delete this particular program. So now we are going to develop a program. We are going to use this model. We are going to implement that model into our program. All right, so we are going to be using OpenCV for this. So we already know about OpenCV. So import CV2. We are going to be importing TensorFlow as TF. So after that, we are going to be importing the NumPy as NP. Fine. Now we are going to be taking the phase, as I told you that we are going to be taking some phase data points which are going to be helping our model to predict more easily. So CV2, we are going to be taking cascade classifier. So cascade classifier, and in this we are going to be using the CV2 dot data dot, we can say her cascades. All right, So after that, I'm going to be taking plus. Now here I'm going to be giving the file path of my XML file, which is this one. Copy path reference, copy, and here I'm going to be giving the reference or the path of that file here. After that, I'm going to be taking the emotion model. Another variable I'm going to be having emotion model. I'm going to be using tensorflow.keras, tensorflow.keras dot models dot load dot model. So this particular line, this particular statement is going to be telling us to use our model which we have developed. So I'm going to be clicking on this copy path reference, copy, and inside this now I am going to be giving my model path, right? So sorry, yep, that's it. All right, after that we are going to be giving our emotion labels, because we have to check out what is the emotion of a person. So we are going to label that person. So what can be certain labels? Either it's going to be angry, the person is angry, or a person is we can say disgust, or a person is sad. So it should be inside, right? So if a person is fear, having a fear, or if a person is sad or happy. So we can take a lot of emotions, but we have developed only 7 emotions. So based on that only we are going to be taking the value. So we can take sad also. So let's take sad. And after that I'm going to be taking the surprise. And after that I can just take a neutral or a natural. So let's take neutral. All right, so these are the 7 parameters which we have taken here in the emotion labels. All right, it's not very hard to understand. We just use our happiest.xml file. We just load our model. We just give the values of our model here. And right now we are just going to define the function. So defining the function is going to be, let's give the name detect faces and emotions. So our model is going to detect the face, as well as it is going to detect the emotion of that face. And we are going to be giving image path here. All right, so that's it. In the next line I'm going to be taking image, which is going to be read by the CV2 IM read. So in IM read we are going to be giving the image path, right? So after that I'm going to be taking another variable which is going to be gray.cv2.cvt color, and it's going to be based on the image which we are going to give, as well as it's going to be having cv2 dot color bgr to gray. We should take not RGB, but it should be bgr to gray, right? All right, so after that we have to detect the faces also. So let's take faces here, faces. Again we are going to be taking face cascade dot detect multi-scale. Inside this we are going to be having gray, which we have already have above, scale factor, so which is going to be around 1.1, right? Because we are not using the color photo, so the program is going to be convert the photo into something gray, and then it is going to be detect the emotion, because it's easy to detect the emotions when the picture is gray. After that I'm going to be taking the min neighbors. That means the data points, the nearest data points, it should be minimum 5, right? So the minimum data points next each other should be 5. After that I'm going to be taking the min size. It should be around 30. Let's take 30. I think so. That's it. That's all the parameters for the faces values which we have taken here. After that I'm going to be taking the dimensions. So for x comma y comma w comma h, which is the universal statement whenever we give the parameters in faces. So after that we are going to be having face dot roi So you can just take any names if you want. So I'm going to be taking gray. So here the parameters is going to be for the 3D space, right? X, Y, W, H. For the 3D space, we are taking this particular parameter. So I'm taking gray, and of course the Y parameter should be always having Y plus H. So these are some universal statements you should learn and murmur, right? Even I murmur all these things, so it doesn't really matter. You should be know that whenever you're using some lines, so this is by default, it's going to be placed there. So after that, we are going to be taking face ROI. It's going to be CV2. Of course, we are going to resize the we can say image or the border outside of the image, the face, so it can automatically resize. So it's going to be face ROI. So it's going to be face ROI, and it's going to be the values which we gave in the last model was 48. Right, so is there any mistake? Let me just check. So resize is going to be face ROI. Yep, there is a mistake. It's going to be comma dimension size. After that, I'm going to be having face ROI, which is going to be again face ROI 255.0. Right, after that again I'm going to be taking face ROI. It is going to be npa.expand. So it's going to be taking expand dims, face ROI, axis. So the values of axis in the starting is going to be 0, and in the second line we are going to be taking the axis value 1. So let me just copy this whole line. Right, so here the axis is going to be 1. So let's take -1. As I said, that positive values always create some problem, so it's better to take -1. So this is actually going to reshape. These two lines are actually going to reshape the model input. So it's going to be reshaping the model input. Now here I'm going to be predicting the emotions. So let's take predictions as a variable. So predictions, emotions, model. So dot predict, we can predict. So face ROI. All right. After that, we are going to be giving the emotion label. It's going to be emotion label in the emotions labels. And after that, we are having np dot argument argmax. Inside this, we are going to be taking predictions. All right, I think so that's enough for the we can say for the recognizing the face. Now only thing which we need is to make border or outline near to the face, so it should recognize what is the face. So for you also, for visually, it's okay to have a box telling that this is the face, right? So let's make some rectangle, cv2 dot rectangle. So in rectangle, I'm going to be taking image, and inside image, I'm going to be taking two parameters, x comma y, and after x comma y, I'm going to be taking another parameter x plus w, as well as y plus h. Again, universal thing to learn and remember. And here I'm going to be giving the last parameter, which is going to be 255, comma 0, comma 0. And here I'm going to be giving the last parameter, which is comma 2. All right, so let's have cv2 dot put text, and inside this again I'm going to be taking image. After that, I'm going to be taking emotion label. Again, I think so it should be x, y should be -20, or let's take y as a size of -5. Let's take this one. After that, we are going to be having cv2 dot font. We are going to be using the font which we want to display. So font Hershey, let's take simplex, right, comma, it should be around 1.5. So you can increase the font scale if you want, right? So you can increase the font scale if you want here. And I'm going to be taking the parameters again, which we have taken above, 255, comma 0, comma 0. and out of the box it's going to be 2. The thickness is going to be 2. All right, so overall we have done a lot of things, right? Now we are going to be at the last thing, which is going to be cv2 dot im show. So this is going to tell us the emotion detection, comma image. So it should be here. So cv2 dot weight key should be 0, and after that it's going to be cv2 dot destroy all windows. And at the last we are going to be giving a last line, which is going to be detect faces and emotions, and inside this we are going to giving the path of our image. So let's try to take this particular image. We are going to be copying up this path, we are going to be writing it here, and once we run the command, so it will take some time. Alright, so there is a problem. Emotion model is having a problem. tf.kera's load model has no attribute load. So there is an error on line 7. Alright, so there is an error on the line 7. Model.load model is having a problem. Right, so tf.keras.models load. Alright, so it's not going to be load.model, it should be this one. Now let's try to run. Alright, so there is any other error. Oh my god, so many errors. Line 18 is going to be having error. So what is error here? So we are having 3 errors, line 36, line 15. So line 15 is having error, faces, min size 10/30, dataset sections, cascade, min size 30, right? So we are having error in line 15. Let's resolve this line 15 error. So we are having faces.face.cascade .detect multi-scale gray, scale factor is 1.1, min neighbors is 5, and min size is 30,30. So it's fine. Alright, so it's hard, right? So we are having a lot of errors. So let's go above and then try from there. So let's go above. Alright, so once again let's check cast fire. So let's alright, so I didn't get the model path again. So let's give the model path once again. Alright, so the program is not having the path. harasscat.xml path also should be there. Right. So this should resolve the issue, maybe. We are going to be checking for the image path as well at the right thing, which is part to the image. Alright, now let's try to run. So it's having a lot of errors. Alright. So let's do it tomorrow, right? We are going to be checking up for this particular problem. So today we have just checked for the model development. Still, like, there is going to be having some errors by using the model. Let's try to do this for the next webinar, in which we are going to use this particular emotion.model.h5, and we develop a program, and based on that program we are going to be having the image. It should work. All right, so it's not working. Maybe we have to make a model again. So let's have a session maybe after some time, after some days, on this particular topic again, in which we are going to develop again, we can say, the model, and we are going to be trying to detect the faces. All right. So thanks for checking out the education diary. And yeah, of course, we are having a lot of errors in the programming. So nothing new in that. So we have to resolve that. But it's going to be really a long webinar if we are going to working on the resolving of this particular thing. So maybe we have to check for my system configurations if it's having a problem somewhere. So yes, we will meet in the next webinar, and we will try to focus on this more and more. Try to check the sentiment analysis by using the image, which was our main task. But for the project one, we already covered that. Project one was pretty easy based on a text. We were having the sentiment, it was positive or negative. But for this project, I think so there is some system configuration errors. But if we are going to do and resolve, it's going to take a lot of time. So let's meet for the next one. And thanks a lot, guys. If you're having any questions, you